During the spring 2018 semester, our capstone group worked with CEI equipment on a throughput improvement project. The group consists of 4 Iowa State University IMSE students: Jack Biesterfeld, Joseph Fedregon, Tyler Jewell, and Jamie Wishart. CEI equipment operates out of Cedar Rapids, Iowa, and produces aluminum feed grain trailers. They're one of the largest domestic feed grain trailer manufacturers. In fall 2017, an IMSE capstone group worked on CEI's welding process. As their suggested improvements are being implemented, there is increasing pressure on the final assembly process downstream. The goal is to increase the throughput of the final assembly, which has become the bottleneck. Throughout the project, we had to develop our solutions around constant workforce and unchanging space constraints. Our objective for this project is to increase the throughput of the final assembly by 20% or 4 trailers. This would result in an output of approximately 25 trailers per month.
During the CSA, we chose to conduct a work sampling study, create a floor layout, and perform a work path analysis. The red slices represent non-value-added tasks, yellow represents non-value-added but necessary tasks, and green represents value-added tasks. We noticed that 23% of the time was spent getting tools and parts. AutoCAD was used to create the current floor layout shown on the left. This allowed the group to analyze workers' movements in the work path analysis. ProPlanner was used to visualize and calculate worker movements. This output can be seen on the right. The work path analysis showed workers excessively fetching tools and parts. The equipment and storage racks are in poor locations, leading to long working paths. After the current state analysis was completed, we decided the following solutions best address the uncovered problems. We designed carts that combined parts and tools and created a new work process approach, an improved assembly layout, and a 5S implementation plan detailing each step of the process.
The new job carts we are recommending include 2 shadow boards for tools, a Kanban wall on either side, and a space for large parts. One cart design was made for electrical workers and the other is for hydraulic workers. Electrical workers have a bin for wire scraps and hydraulic workers have hooks for larger hoses to be placed. In addition, the table was designed with shadow boards and a Kanban wall for the general assemblers to put together flow and sequencing valves. These are examples of shadow boards to be used on the job carts. The board on the left is for electrical tools and the board on the right is designed for hydraulic tools. Workflow is redesigned around hydraulic assembly bottlenecks by allocating electrical assemblers tasks more efficiently to avoid idle times around the rear of trailer units. Electric-powered tools were suggested from multiple members of electrical and hydraulic assemblers that complained about dragging air hoses around to drill holes in a unit. The General Assembly Manager also suggested that engineering redesign parts that needed holes drilled by electrical assemblers be pre-cut by the laser cutter to speed up the installation of light fixtures.
A new floor layout was created in AutoCAD and is shown on the right. This layout mostly resembles the implementation of new tool carts, elimination of storage racks, and a relocation of equipment and outsourced parts. A ceiling-mounted crane has also been suggested. This would provide fall protection while eliminating the need for A-frames, which are difficult to maneuver. The current state and future state ProPlanner outputs are shown. The work path of one electrical worker is shown in red, while a hydraulic worker is shown in green. The improved layout shows a theoretical reduction of walking by 21.5%. A 5S plan will be implemented and should follow the steps of 5S: sort, straighten, sweep, standardize, and sustain. This includes sorting and removal of storage racks, creating floor outlines, cleaning the workspaces, using a cart checklist, and a sustainability audit. This plan will reduce non-value-added time, free more space, and identify problems not addressed by our group. The average selling price of a trailer is $83,000. A 4-year per month increase in throughput will result in $334,000 of additional sales per month. The cost to implement our recommendations is approximately $78,000. We would like to thank Dr. Sly, Dan McDowell, and Jim Stolk, and everyone else who helped make this project successful.